Hello! In this lecture, I'll talk about the requirement specification. In short, the requirement specification is the process where we can create a document of requirements. As you probably remember, there are two types of requirements, user and system. User requirements are made for your clients and do not involve specific technical information. At the same time, system requirements are more detailed and may include technical information. The requirements specification documents sometimes become part of a contract for the system development. That's why these should be as complete as possible. There are many ways of writing requirement specification. I would like to highlight the most popular and the most important ones. Firstly, we can write specifications in natural language. This is mostly used at the initial stage of product or system development. When we meet a client, we can make notes of many things he says. Later on, these notes should become a formal document with numbered sentences, also written in natural language. Each sentence should express one requirement. This method has many disadvantages. I will present them later in this lecture. To avoid disadvantages of natural language, the structured natural language could be used. In this case, where requirements are also written in natural language, but on an agreed form or template. Each part of the sentence provides information about an aspect of the requirements. Here we can take an example of user stories that have a defined structure for each requirement statement. Similarly, structured languages are used not only for requirement specification, but also in other activities. For example, in testing, Graham syntax is used where sentences for testing are written in similar structured language. That's why these sentences are understandable not only for system developers. Another type of writing specification is using graphical notations. It is basically used to write functional system requirements using graphical models together with syntax annotations. It usually includes UML, use cases, and activity diagrams. When we need a formal description, mathematical or model-based specifications could be used. It is a very important part because model-based specifications can be validated. In other words, we can check the consistency of requirements. These notations are based on mathematical concepts, such as finite state machines or sets. Also, in this part, modeling approach is relevant. Let's take a look at each specification type separately. So, natural language specifications are requirements that are written as natural language sentences. These sentences might be supplemented by diagrams and tables. This method is expressive, intuitive, and universal. To illustrate how natural language requirements are written, let's take an example. A person shall buy a black car in order to drive. He must have at least 18 years old. He shall not buy more than 2 cars. Now, what should be considered when writing requirement specifications? Well, first of all, you should maintain integrity and use a standard format for all requirements. Also, use language in a consistent way and highlight key parts of the requirement. Furthermore, avoid the use of computer jargon and include an explanation of why a requirement is necessary. As I previously mentioned, natural language has many disadvantages, and I would like to mention some of them. Firstly, this type of specification lacks clarity. If we want to explain many details, we need to write a lot. And if we want to describe everything in short, some parts of the requirements might remain unclear. Another problem is requirements confusion. Usually, in natural language, functional and non-functional requirements are mixed up. The last one I would like to mention is requirements amalgamation. Then we merge 2 or more requirements into one. Let's move on to the structured specifications that are written in an agreed form. Structured specifications are very popular nowadays because of the wide adoption of the agile processes. As you may know, the sentence form requires pinpointing the actor or the role of the user who initiates action. Also, it requires expressing the main functionality using a verb. And finally, it requires writing a reason that might be an extension of the main functionality. This form is not set in stone, and there are other forms for writing user stories. Let's take a Jira software. Actually, Jira itself is not restricting the sentence form, so the team members need to follow the agreed form themselves. Take a look at the earlier example, only written in Jira. As a person, I want to buy a car so I can drive it. As you probably noticed, some parts of the requirements are gone, like age, the number of cars, and color restrictions. If you look at details of this user story example, you could see that all these requirements are written in description part. It is important to know an acceptance criteria, usually marked as AC, that shows when the activity is finished and how to check it. Requirements are mostly marked as RQ with a certain index. In our example, we have 3 different requirements. Car must be black, person must be at least 18 years old, and person should not be able to buy 3 cars. If you don't like the description form, it doesn't mean that you cannot use this tool. Jira has many plugins, and we urge to install and try out requirements management plugins. Let's move on to the next type of requirement specification, that is graphical notations. Let's overview UML use case diagrams. Use cases identify actors and describe iterations. A set of use cases shows possible interactions with the system. This is a high-level graphical model that can be used together with more detailed tabular description. Also, UML activity diagrams may be used to add even more details to the use case scenario. Now remember our example about requirements of buying a car. As a person, I want to buy a car so I can drive it. Actors in UML are described as so-called stickmen. For the part as a person, we only need to create a stickman and call it a person. For use cases, we have to create bubbles with activities written inside them. Every use case starts with a verb. In our example, a person has an activity, buy a car. Then, drive a car is another use case of a person. The relationships are shown as connections between use cases. Here, the extend pointer shows that a person can buy a car but not necessarily drive it. While person car and salesman car connection shows that for a person to buy a car, there also must be a salesman. Additionally, I would like to present form-based specifications as these are commonly used as an extension in UML use case diagrams. Forms usually define functions or entities, describe inputs and where they came from, outputs and where they go to, pre- and post conditions, and other things. As you can see in this slide, it would be hard to write all information in the UML use case diagram, so all specifications and additional information are described in separate tables. In this case, the buy a car bubble or use case is described in Table 1 in more detail. It shows information like a goal, description, precondition, actors, related use cases, and post-condition. Finally, let's overview mathematical or model-based specifications. And let's take an example of Object Constraint Language, or OCL. Actually, this is used in the UML diagrams as a part of object specification. Using properties and constraints, we can write similar sentences as it is shown in the slide for all objects. For example, if we take an object vehicle, the first sentence, a vehicle owner must be at least 18 years old, could be written in this form. The context is that a vehicle, look at the diagram, and its connections, owner number 1 in the diagram connection line, property age should be equal or higher than number 18. If we have a derivative object, car, we can put similar constraints on it. Then, the sentence, all vehicles of the person are black, is like an opposite so-called fleet connection, and an object is a person that shows that all cars must be black. If we have this type of sentence, we can generate various tests and make automated verification for our system. Key points of this lecture. The specification is the process of writing down user and system requirements in a requirements document. The requirements specification may be part of a contract for a system development. Different techniques can be used for the requirement specification. The choice depends on the project, team, organization preferences, and other factors. Thank you for your attention.